All right, so this is the first video where we're going to look at simplifying rational expressions, which was the first assignment of 3 in the last section of your online module. And let's jump right into it. I look at my rational expression. This is a quadratic. The coefficient of the leading term is 1. And this is another quadratic, and the leading coefficient here is 3. So I'm going to work on this one because it's going to be a little bit more challenging because of this 3. And then I'll leave this one that looks a little more like our standard form, where our coefficient is 1 for our leading term. We'll do that towards the end, okay? So I'm going to start with the diamond problem. It's a strategy we can use. And the idea here is this. If I multiply my constant with this leading coefficient, 3 times negative 8, I get negative 24. And then I take the coefficient of the middle term with its sign, and I put it down here. Then I ask myself, what two numbers, A and B, can I multiply to get negative 24? And also, if I add or subtract, I get negative 10. Okay? So I'm going to list all the factors of 24. So I'm just going to go 1, 12, 2, oops, that's not 1, 12. 1 and 24, 2 and 12. I have 3 times 8, and I think 4 times 6. Now, this one jumps out because I'm saying, oh, 4 plus 6 is 10. Okay, but since it's negative, both of these have to be negative. But what happens when I do that? Well, negative times a negative is a positive, not a negative. So that gets eliminated. And in fact, the one that works is going to be this guy, 2 and 12. Because the middle term is a negative, the biggest value of this pair has to be negative. That makes the other positive. Okay? Once I have that set up, then I go ahead and use my area model. Now, I start with the leading coefficient, which is 3x squared, or leading term, and across the constant. And here, I'm going to put these two terms, which if I add, give me negative 10x. So I got positive 2x minus 12x. Now I find the dimensions of this, or the area of this square, right? Base times height, so I know this has to be x into x. Now, if I put 3 here, it's more likely to be in the correct position because then I can multiply it by negative 4. If I would have put 3 here, 3 times what gives me 2? That's not going to work. So usually the area model will guide you into where that leading coefficient value is going to go. X times positive 2 gives me 2x, and positive 2 times negative 4 is negative 8. That checks. Now, I'm going a little bit fast because I'm limited with how much recording I get. So I'm going to go down here and write the factored form of that quadratic. I have 3x plus 2, and then I have x minus 4. Now, in doing the same thing here, I'll erase this area model. I'll just show you how to use a diamond problem. All I do, now I'm looking at this top one, this is 1. So 1 times 16 is positive 16. And the middle term is negative 8. Oops. A lot of erasing. So again, what two values can I multiply? I get 16, but also add, I get negative 8. Well, in this case, negative 4 and negative 4. This is negative 8. When I multiply, I get positive 16. So I'm left with x minus 4 times x minus 4. And now I can go ahead and look for my giant ones. This simplifies, and I'm left with x minus 4 divided by 3x plus 2, where x cannot equal, and don't forget, x can't equal 4, or in this case, negative 2/3. And that is my final answer.